So in this video, we're going to look at how we name covalent molecular compounds that are not acids. So two nonmetals can combine to form what we call a binary covalent compound. And the rules for naming binary ionic compounds are fairly simple. You give the name of the first element in the formula completely unaltered. And then you take the name of the second element, but just the root part of its name, and add to the end of it the letters IDE. So the same ending as for anions. And then what we do is we apply Greek prefixes to each of those two components to indicate the number of each of the atom types that is present. So we're going to need to know these Greek numerical prefixes in order to do this. So you need to memorize them. Up to about 10 is just fine. You don't need to really go much further than 10. So it is important to not confuse them with the Latin prefixes, so things like uni, bi, right, quad, and so forth like that. That might be familiar to you. The 3 is ter, okay? So that's something to be aware of. I always say, you got to do these, you have to know it if you're going to study chemistry, so don't stress about it, just get it done. And memorizing these isn't a total waste of time. Impressing friends at parties with I just drank a hexapack sounds a lot better than I just drank a 6-pack. Okay, so let's have a look at some of these rules in action, and you'll see some of the exceptions that we have. So the first exception that we're going to have is that we don't ever put mono when there's only one of the first element. In fact, mono is often excluded. We'll talk about that in a moment. So no mono if there's one of the first element. And then the other thing that's kind of a bit of an exception is that prefixes are often omitted if the compound contains hydrogen. So this one here is a good example of that. We'll talk about this a little bit more in a moment. So people will also write that as hydrogen oxide. So they eliminate all prefixes if the compound contains hydrogen. So we've got one carbon, one sulfur, right? So no prefix for one of the first atoms, so it becomes carbon. And then we're going to write for sulfur, we write the stem name, add the letters IDE. There are 2 of them, so we add the prefix di. Okay, so let's do one that, so here's another one, carbon, first name unaltered. Second element is oxygen, so it's going to be oxide. And then we add prefix, no prefix needed for 1 carbon. For 2 oxygens, we need di. It's the same thing again. Let's do something a little more exotic. What about if we had N2O4? So we've got first element unaltered. Second element, change the ending to "ide," and now we need Greek prefixes for each of them. There are 2 nitrogens and 4 oxygens. So dinitrogen tetraoxide. So there's a bunch of these guys here. So you can see there the exception, that the big exception that we're using here is that if there is only one of the first element, no need to put the mono there. The formula and the name follow the same sequence of atoms. Okay, so sometimes they have a description of the compound that is formed between these elements, and so you have to decide what comes first in the name and the formula. And general rules of thumb are oxygen and the halogens come last. If you do have 2 elements that are in different groups, then the lower group comes first. So a good example of this is the compound between nitrogen and oxygen is going to be written like that. Forms between nitrogen and oxygen is going to be written that way because for 2 reasons. Oxygen comes last, and then the element with the lower group number always comes first. So this guy's in group 5A, and this guy's in 6A. So you've got two reasons to put the oxygen last. Now, what about if the elements are in the same group? So a good example of this is sulfur and oxygen. Sulfur is in group 6A, oxygen is also in group 6A, and what we say is the one in the higher period always comes first. So oxygen's in period 2, sulfur is in period 3. So whenever sulfur and oxygen combine in a compound, the sulfur always comes first. Okay, so they're just kind of some general rules there. You typically write the atoms in the order from lowest group to highest group, and then if they happen to be in the same group, you write it from highest period to lowest period. So pretty simple kind of rules. Okay, here are some examples here where we're using the rule, or here is a example where we're using the hydrogen, if hydrogen is present, omit prefixes. So hydrogen chloride here, from the name, we don't actually know how many chlorides are present, do we? So it is, hydrogen is the first element, then the stem name of the second element, plus IDE, and because hydrogen was the first element, we have like no prefixes, right? Okay, so that's an example of that exception coming into play there. So if I'm going to name these guys here, this guy here, it's going to be hydrogen. It's my first element, unchanged. My second one is sulfide, and because there's hydrogen as the first atom, I'm going to leave no prefixes. Here's this guy here. Interesting compound. It's got a noble gas in it. Very few of those. Xenon, my first element, unchanged. My second element is fluorine. Change the ending to IDE. 1 of the first element, no prefix. 6 of the second, so it's got to be hexa. Xenon hexafluoride. Okay. Here's this guy here. First element, unchanged, chlorine. Second element, change the ending to "ide." There are 2 chlorines, so it's going to be dichlorine. And there are 7 oxygens, heptaoxide, hepta for 7. Now, something to be aware of is that a few compounds have what we call irregular names. And we never use this naming system, or very rarely do you see this naming system used for them. And the big ones that we're going to be seeing are NH3 for ammonia, and H2O for water. And then sometimes we're going to see, well, we're going to see this not as much, but H2O2 for hydrogen peroxide. Okay, so you know, these names we're going to just see, and people are going to assume that you know what they are. So yeah, that's it really, short and simple. Leave the first element's name unaltered, change the ending of the second element's name to IDE, and then apply Greek prefixes to indicate the number of each atom type present. If your formula begins with hydrogen, you don't have to worry about the Greek prefixes. And if there's only one of the first element, you don't have to worry about the mono. Okay, so that brings this section to an end. I hope you found the video helpful.